Go for it. Stop sharing for a second.
Okay.
And click share again, because the monitor's on. It's this one.
Okay.
That's why. Because I was seeing this screen.
Okay. Cool. All right. I think tech issues are figured out. Can you all hear me okay?
Yeah.
Cool. Well, thank you all for coming to see me talk. Hopefully you can learn a few things, and feel free to ask me questions afterwards if there's anything you want to talk about. So this is infrastructure as code, how to abuse Terraform to elevate access. All right. Okay. Now tech issues are solved. Cool. So quick intro. I'm Mike McCabe. I run a company called Cloud Security Partners. We do a lot of cloud security testing and building, remediation, all the kind of wonderful cloud security things. I've done a lot of work in the infrastructure as code field, so a lot of Terraform work, hence this talk. I like talking about it. You're probably all going to run into it at some point if you work in corporations, if you work with app teams, or if you're a red teamer, pen tester, whatever, who works against environments that use Terraform. It's a really interesting topic from the security perspective. How many folks have heard of Terraform, used Terraform? Okay, all right. It's a pretty good handful. That's good to know. For anyone who isn't familiar with it, it's infrastructure as code. So what that means is traditionally we used to do something called ClickOps, where you go into the AWS console, you set up your EC2, you name it, test 1, 2, 3, you forget to delete it, you get a bill for $40 every month for 2 years. So that's the traditional way we used to do infrastructure, but that doesn't scale well. When you're working in a corporate environment, a big enterprise, you're probably working with hundreds of accounts, thousands and thousands of resources. So you can't really do a manual deployment of all your infrastructure. So we moved to tools that are called infrastructure as code. Terraform is one of them, but there's other ones as well. There's CloudFormation. Azure has their own tools. There's OpenTofu now, which is a fork of Terraform. So there's quite a few out there. And like I said, Terraform is open source, sort of. They just changed the license, so it's now a more business friendly. And HashiCorp, who created Terraform, just got bought by IBM. So, We'll see how that goes. I'm not super hopeful that they'll be a good steward, but we'll see. But with Terraform, you can create, modify, and destroy your infrastructure in a consistent and repeatable way. The big thing to think about too is it's stateful. So I'll come back to that. So some of the benefits of using something like Terraform and infrastructure as code, like I said, traditionally we did ClickOps, go into the console. With things like Terraform or other tools, you centralize those deployments. You have one pipeline. You might have multiple, but at least you have in an official pipeline versus kind of deploying things ad hoc. Everything is codified, which means all your infrastructure is in source code. That means it's in GitHub or GitLab, or if you're still in the 2000s, Bitbucket. Some people always laugh because I know there's some people still stuck with it. So. And the important thing is you can apply security controls to Terraform and infrastructure as code as well. What are some of the challenges? A lot of times with all CI/CD pipelines, they're given really high privileges. Does anyone know if the admin access, if you're in AWS shop, is the admin access policy tied to your Terraform pipeline? Anyone? No? No? Okay. Every time I do this talk, at least one person's like, yeah, I should look into that because we definitely have the admin access policy tied to our Terraform user. So people often just give their pipelines, full access to do whatever they want because they figure it has to deploy infrastructure, it needs to have full access to everything. But that's kind of the first mistake. And I'll talk about the ways that you can use Terraform to execute code to elevate access and gather more information. So it's an interesting tool in that way as well. And there's some issues around security controls, which I'll talk about. So my experience in this area, we as a company have worked with a few different large enterprises building out their infrastructure as code pipelines. So we helped them define how to do that. We wrote thousands of rules that are basically security controls that are codified against their Terraform. And the big benefit, if anyone is on the blue team side here, is that everyone in the cloud has struggled with thousands of findings. If you all have like a cloud monitoring tool, I'm sure there's hundreds, if not thousands, of findings in your environment right now. And what we've done with these tools and Terraform deployments is basically bring those down to like very, very few misconfigurations, and really what people struggle with are vulnerabilities on Docker images, on VMs, things like that. So it's a really powerful preventative control in the cloud space, and I'll talk about some of that in a little bit. So just to start, what does this actually look like? If you're familiar with any CI/CD pipeline, it's mostly the same. You have developers who commit code on the left side into GitHub, something along those lines. In this case, I'm using the example of Terraform Cloud, which is a cloud-based Terraform product from HashiCorp. You don't have to use Terraform Cloud. You can just run it on Jenkins on one of your servers. And then the Terraform Cloud or your server reaches out to the different APIs of those cloud providers and does the actual work. So it's not that much different than an app pipeline. Instead of deploying app code, you're deploying infrastructure. So like I mentioned, Terraform is stateful. So what that means is, unlike Ansible or Chef or Puppet, you don't just run a script and it goes out and does some things and it gives you some output. Terraform actually tracks the state of your environment, and how it does that is before you run and create something, you do a plan. And a plan takes all your Terraform code and it determines your dependencies, as in what needs to be created before something else has to be created. It determines what the output's going to look like, and it determines what it doesn't know, which are called unknown values, which is important from a security perspective. So it does a lot of pre-work before it does any actual real work in the environment. At that point, nothing's really changed in your environment until you do a Terraform apply. That's when it takes that plan and it actually goes out, creates your infrastructure, updates it, deletes it, whatever it might be, and then it outputs those changes. And importantly, it updates the state file, which I'll talk about. So anyone not familiar with Terraform, this is a really simple example, but this is all you need to deploy an EC2. AWS instance is the resource that's basically tied to EC2. Resources are all your different types of resources in AWS or Azure or what have you. DB instance would be like an RDS, things like that. So Terraform is a really simple language. That's what makes it powerful, is that you don't have to write a lot of code to do what we did in the console for such a long time. So you can run this right now and deploy out an EC2 in 5 minutes. But behind the scenes in that plan, there's a lot more going on than what you see, which makes it interesting, because although to you you're just deploying an EC2, you're defining a few things like the AMI. Terraform in the back end is defining a lot more things than that, and that goes into this, which is the plan. The plan is a local file, or you can host it in something like Terraform Cloud, and then it's a binary, but you can output it as JSON. You can see what all the different pieces are. And if you're paying attention, you can see there's some interesting things here, like get password data. That's an interesting field in the properties of this EC2. So there's all this kind of hidden configuration behind the scenes with Terraform that it kind of abstracts from you, that you don't have to know if you don't want to know. But as a security person, there's a lot of interesting angles with this that you could play with. And get password data actually gives you a Windows password if you're deploying Windows EC2. And so like I mentioned, Terraform is stateful. So it goes out and it creates the infrastructure, and then it tells you, it updates a file that tells you what is out there. So there should be a one-to-one mapping between what you deployed in your plan, what's out there in your AWS, and in your state file. And the point of that is to manage the state of your environment from one place. So instead of running a script and it goes and updates something, then you go in the console and update something, then you run a different script, you run everything through Terraform, you keep the state up to date with what the environment looks like, and you can use that to update and manage things. A lot of times what companies run into is they use Terraform to deploy things, then people will manually go and change things, and that creates a conflict between the state and what's out there, and there are ways to fix that, but that's a pretty often seen thing with infrastructure as code. So you really want to use just Terraform to deploy your infrastructure and just Terraform to update it. The other fun thing about Terraform state is any secrets that you deploy through Terraform are going to end up in the state file. So if you're deploying something like an RDS instance, when you set up an RDS instance, the master password is dumped out to the state file because it has to set one, it has to give you that database password back, and that ends up in the state file. This is an example of a AWS secrets manager secret. I don't recommend you ever use Terraform to create or manage secrets. It's not a secrets management tool. but it does give you the ability to. I've seen instances where it is used that way, but just know that if you deploy a secret through Terraform, it's now in your state file basically forever. So now your state file is also a secrets manager or a key manager. So it's good to know that these values are out there. And you can see in this example that the secret string is, it's just an example string, but it's sitting in plain text in your state file. And HashiCorp is aware of this. I like this image because this is a GitHub issue that was opened against this issue in Terraform in October of 2014. I took this screenshot last year, and you can see Omar from HashiCorp is saying, like, yeah, we're aware of it. This is on our roadmap to fix. Then I took this screenshot. This was a few weeks ago, and they're still working on it. They still have an open issue. They made like no progress on this whatsoever. So I feel bad. I've been slandering Omar for a year doing this talk, but they kind of have to get to it. What's interesting, I mentioned OpenTofu is a fork of Terraform because of the license change. They're actually working on this as kind of a priority feature to address unencrypted secrets. So it's definitely good that they are at least working towards fixing it. It's a big architectural change, so it's not easy, but HashiCorp is worth billions. They should be able to fix this. I'm sure IBM will solve it. You got to have one meme per talk. So when people ask, where should you keep the state file? I think it's kind of a hard question to answer because what are you the best at keeping secret? Like, where can you keep files the most secure? If S3 you have a lot of active protections against, you have like block public access turned on, if you have good monitoring, if you have automated remediation so that public buckets become not public, if you have good IAM controls to make sure that not everyone in the company can access every single bucket, then S3 might be a good solution. But if you all have terrible controls and you can't promise that this very sensitive file is going to be stored securely in S3, I recommend somewhere else. So it's really a case-by-case basis. It's not like use this one secure solution. What is the safest place you can keep a file secure and monitored? That's really up to each environment. Terraform Cloud and Terraform Enterprise can manage the state for you. There's another tool called Spacelift, which is a managed Terraform provider. They can also manage that for you as well. The other kind of piece that's important to understand about Terraform is it itself can't do much on its own. It's a language specification. It's a binary that interprets Terraform. But without providers, it can't really do much. And providers are the glue between Terraform and all your cloud APIs or whatever it might be. So this is a list of providers that HashiCorp provides. This is not a complete list. They have dozens and dozens. But you can see they have support for all the major cloud providers. They have support for subsystems. They have like Helm providers for Kubernetes. They have Kubernetes providers. They have a lot of different providers. There's a ton of open source providers as well that, if you want to go write a provider right now, you can. It's all just Go based. There's a spec for how to write a provider. So it's not incredibly difficult, and there's a lot of them out there, but it's another kind of dependency that we're adding to our whole application stack. We struggle with Ruby gems and JavaScript dependencies. Now we're adding a huge amount of code that is coming from the open source that we don't have good tooling around, to be honest. And I think this is sort of interesting because this is a count of the lines of code of the AWS provider from HashiCorp. So I took the top screenshot and then 6 months later took the next screenshot, and you can see it's all Go. So it's about 2 billion lines of Go, and then in 6 months they added another, I think that's, another like 40 million lines of Go. So it's an insanely large code base that you're pulling into your environment, and that's one provider on top of a lot of different providers. You're not just going to use one, you're going to use a lot of different providers. So if anyone is familiar with all the supply chain hacks that have happened, you're now pulling in untrusted infrastructure as code. And like I said at the beginning, a lot of these pipelines have full access to your environment. So if you pull in a sketchy provider that does something malicious, you've now just given it admin access to your environment. One other area of concern is all the APIs that Terraform exposes if you do use hosted providers like Terraform Cloud or Enterprise or Spacelift. It's a really interesting area to abuse because you can do things like pull out the state file, run plans, update state files, all those kinds of things that are another area of concern with these tools. So the attack surface for this is really big. Another fun little thing that HashiCorp did in their wisdom is generally when Terraform runs, it's assuming a role from an EC2 into the environment to do its work. So it's assuming a role, and as part of that, it gets temporary credentials. For some reason, the AWS provider dumps those credentials out to the log file. So if you're a developer or if you're a malicious insider, all you have to do is set the tflog environmental variable to trace or debug, and you basically get the credentials to that pipeline. They're short-lived, depending on how long you have your STS role for, but there's just an oversight in HashiCorp, and this is the AWS provider. There's a lot of different providers. They all kind of suffer from similar issues, but if you don't have full access to production, you can just use this to get a temporary role or temporary session to production via the log file. And setting environmental variables is pretty common for developers. So I like this image because I'm a fan of Terraform, but for use by competent persons only. And I love this because at some point this probably didn't have that warning on there, and yeah. So to talk about some of the techniques that we've discovered and used and built protections around. I'll get into those. I just want to say, if you find this topic interesting, there's a huge amount of research to be done here and to kind of dig into inside Terraform, inside OpenTofu, inside all the other tools. There's a lot of attack surface here to really mess with. So this is only kind of scraping the surface based on what we found. The first one I want to talk about is remote exec. So if you're a developer, if you're deploying infrastructure, you're supposed to use Terraform to deploy your EC2, then you use something like Ansible, Chef, Puppet, whatever it is, to really configure the instance. Terraform doesn't want to play in that space. It wants to set up your infrastructure and you configure it the way you want. But they give you a way to do that, which is basically running remote scripts on whatever you set up. And they say these provisioners are not really meant to be used, but they're kind of a last choice if you don't have something else. And they're pretty commonly used across the board. So how remote exec works is you set up an EC2, and then you can use remote exec to basically do anything you want on that instance. So in this example, we're setting up an EC2, we're connecting to it, and then we're netcatting back out of the environment. So the idea being, if you work at a startup and you're like, everyone has root access to every single server in production, or you don't even have a real production environment, this might not be applicable. But if you work in an enterprise where you don't have anything beyond read-only access to an environment, or you can't get root onto your servers, you can basically use this to bypass those controls to run whatever you want on those EC2s. So, as a developer, you set up an EC2 through Terraform, you run remote exec, you get a shell back onto the box, and then you basically got it into production without really breaking any security controls, and you can do whatever you want from that perspective. Again, it applies more for places that have stricter rules about getting access to production. I've worked at plenty of startups where people are logging onto the production database to run SQL queries, so it's very different depending on your environment. But it's one way you can get remote access into anything that you set up in Terraform. Along the same lines, there's local exec. So where remote exec runs on the remote server, local exec runs where Terraform runs. This is pretty commonly used. I see this used with scripts to do like database deployments where as Terraform is running, they're running local exec to do scripts to check if databases are up, run migrations, posts, set up all those types of things. But like I said, if you have a highly privileged role in Terraform, you can use local exec to basically dump out those credentials. I was messing with this when Terraform Cloud first came out, and you could get access to the metadata service through this. In this example, you can see, well, hopefully you can see, but we're basically curling the EC2 metadata service. If you're not familiar, that's a local address on every EC2 that gives you your STS credentials. there's been a bunch of pretty big hacks based on using SSRF and then hitting the metadata service to get the EC2 role. So in this kind of scenario, if you're a malicious developer or you're a red teamer who has access to a pipeline, you can run the scripts, dump out the STS credentials, and then use those to access the environment with whatever role Terraform uses. So I always like talking about some protections to not just give you the problem, but actually give you some solutions as well. Are people familiar with semgrep? I don't know if there's a big AppSec group here. Okay, a couple. I'm a big fan of it. Basically, it's like an enhanced grep. Everyone knows grep. And it's a semantic grep, so it adds some kind of sugar on top of grep to make it more useful. So if you were, if you're a blue team and you're trying to defend against these things, it's pretty easy to use something like semgrep to look for these patterns. There's actually stock rules in semgrep to check for these things that we wrote and got pushed out. But the nice thing about them is if you're trying to prevent these types of attacks, just use semgrep in your pipeline to look for developers pushing this type of Terraform. So all you really need is this one line, which is pattern inside provisioner. So it's really straightforward. That's why I like the tool. Terraform is a really interesting data gathering method as well. There's a lot of built-in tools that I think are interesting. And obviously, if Terraform has wide access to your environment, you can use it to get more data about the environment. And I'll talk about a couple of those. So the first one is there's a built-in HTTP provider. It's a really simple provider. As of I'm aware, it can only do GET requests still. It can't do POST requests, PUT requests. It can't do headers or sessions or anything like that. So it's really simple. But having a foothold into certain environments, even if it's a really simple foothold, I think people know is pretty dangerous. So in this case, again, I'm using it to hit the metadata service. I'll just keep picking on that because it's a pretty well-known weakness in EC2. And just hitting that to get the role credentials again. So if you use that, it makes a GET request to that endpoint. When you do a run, it dumps out those credentials, you use those and pivot elsewhere into the environment. So again, solutions, these things are really easy to solve. The nice thing about Terraform is it's a very simple spec, so to write protections against it are very simple rules. You don't have to have a hugely complex static analysis tool to prevent these kind of things. Another example is something called external data. In Terraform, there's resources, which are your active resources, EC2, RDS, whatever it might be. And there's data, which can be static data. It can be like an IAM policy. It can be SSM parameters. And there's this feature called external data, which, again, HashiCorp makes some odd decisions, but it's basically a way to run scripts locally. And so it's another way that if you're being malicious, trying to use a Terraform pipeline, you can run a script wherever Terraform runs. Again, if that's like in a, we often see that in like a CI/CD account that has a lot of privileges. It's another good way to abuse Terraform to get access to things. And as the work we've done with people kind of securing these pipelines is kind of whack-a-mole, where we keep finding new ways to get around the security controls we put in place, and to, we don't want people to have privileged access to production, and there's just all these different ways you can use Terraform if people are using it in their pipeline to kind of get around those controls. Another fun one, this is again using local exec, but basically using it to iterate through all of your secrets and dump those out. So if your Terraform pipeline has read-only to basically everything, which I see pretty commonly, just write a script to basically dump out all your secrets in Secrets Manager out to your log. So those are a few of the ways that Terraform can be abused. If you're interested in kind of learning more or experimenting with this, there's a couple projects that we have. We have a training platform that is basically a repo full of these examples. There's slides you can run through. There's a half-day and a full-day course built into it. We do it at conferences as well, but this is all open source, so if you want to just set this up locally, this will run you through how to do remote exec, local exec, pivot between the two different environments, all those types of things. So it's pretty fully featured. The slides for a half-day and for a 2-day training are in there as well, so it should be pretty self-explanatory. And you can see there's quite a bit of infrastructure built in there, so you can run through all of these examples. And then also there's some grep rules, OPA rules in there to help you defend against these things too. So it kind of teaches you both sides. We're working on a working on a Terraform module that has all these scenarios kind of built into it. The idea being, if you're doing a red team test, if you're trying to hack something, I'm not going to judge you good or bad, but this is basically a module that will enable all these different attacks. You can just feed in some variables to it. If you want to do a remote exec and shell out to your server, if you want to do local exec and grab credentials or secrets, this has all those things built into it. We're kind of adding different scenarios and trying to make it as modular as possible. So this is open source and kind of a work in progress right now, but it has a few examples built into it to work off of. So use for good only, I guess. That's my get out of jail free. So I also wanted to talk about some other ways to do more in-depth testing. So again, I'm more of a blue teamer. I enjoy red team things, but I'm more of a blue teamer, so I'm always going to talk about how you do defense against these things. I know defense is boring, but that's who pays the bills most of the time. So like I said, SemGrep is a good tool for these kind of things. A lot of them are very easy specifications to look for, remote exec, local exec, but when you get past that, you can get into some really interesting and malicious use cases that you need more in-depth tooling for. A couple of the tools out there, HashiCorp released a tool called Sentinel. Again, it's a paid tool. You have to have Terraform Enterprise or Cloud, so that's up to you if you want to go that route. And Enterprise is super expensive. There's another tool called OPA, Open Policy Agent. The language is called Rego. I guarantee it will break your brain if you read really large, complex rules in OPA, but it is free and open source, and that's always nice. So a couple of examples of how you write Sentinel policies to prevent certain things. I think one of the points I try to make with this presentation is these are like very malicious use cases, but they're easy to protect against, and people should be doing things to prevent them right now. It's not like you have to deploy some crazy tool to address this issue. You don't have to spend millions of dollars. You can address it today with open source and free tools. So here's an example Sentinel policy where we're basically defining a bunch of allowed types, and we're going through our plan file, and we're looking for all the instances, and then doing a comparison against the instance type with our allowed list. So it's a really simple rule, 16 lines of code to basically prevent people from using the wrong instance type. So these rules don't have to be super complex. They don't have to be hundreds of lines of code. If anyone's ever done SAST before in AppSec, they know how complex they can get. It's not like that for Terraform, at least. Another example, maybe a little more complex, but really not that complex, is looking at the Terraform provider, looking at the role that was provisioned through it, and then validating that it is using the right role that you want it to use. So again, instead of, if a malicious user was trying to use a more powerful role to run the Terraform, you can use this policy to basically prevent that from happening. So Sentinel's not an amazing tool. It is homegrown from HashiCorp, so plenty of edge cases and weirdness, and it's, but it's not a bad solution. This is OPA. Again, this is free and open source. It's kind of an odd language. It can be used for a lot more things than just Terraform. It can be used for validating code, validating IAM policies. It's meant for a lot of different things. But it does have support for Terraform, and so it can import your plan. It can look at your block device configurations. In this case, we're looking for encryption, and again, it's 20 lines of code to check for encryption in your environment. So really simple rules. They can get much more complex, but the point is these rules are relatively simple compared to a lot of the tools that we use elsewhere. And in terms of how you deploy these types of rules, I always think about it like this, where you have your pre-plan and your post-plan rules. So pre-plan, you just have your Terraform. It's not been kind of wired together in the sense of all your dependencies haven't been defined. SemGrep's a really good tool there where you're just looking for bad patterns like remote exec, local exec, whatever you have. And then post-plan, when you do your Terraform plan before you do an apply, you use something like OPA or Sentinel to basically take that whole plan file and say, is this relationship correct here? Is this role set correctly on this EC2? Things like that. And that's before you do the actual apply. So that's how I kind of see those two pieces working together. Same kind of similar example. So plan, Sentinel policies, apply. I mentioned it a little bit at the beginning, but a fun kind of edge case with Terraform is, again, it's a stateful tool. So it knows what it knows, and it doesn't know what it doesn't know. Not to be Donald Rumsfeld, but basically when it does a plan, if it doesn't know what a value is going to be, take an ARN, for instance. ARNs are generated when a resource is created. It can't say what that value is. So if you're writing a Sentinel rule, OPA, semgrep, whatever it might be, and you're working off something that's unknown, it will basically skip that check. We ran into this with Sentinel and worked with HashiCorp to find ways around this, but you basically have to explicitly ban after unknowns. And the interesting thing is if you don't have these explicit checks, if you're trying to get around these security policies, if you can force values to be after unknown, which means making it, like using a dynamic value, you can do this with like dynamic blocks in Terraform. You can do it by having dependencies on things that aren't generated. There's a lot of different ways to make it after unknown. It basically bypasses those checks because it moves it into a different part of the plan where those checks won't see it. So we use this to basically bypass some of the security controls and then showed how we have to build explicit checks for all these after unknowns. And it's not really a traditional security gap, it's just the way that HashiCorp or that Terraform works. Terraform can't know a value before it exists. That's just the way it goes. So you just have to have explicit checks against these things. So kind of some final thoughts on the defensive side. I think the big thing when we're building these pipelines, if you're a red teamer or a blue teamer, is understanding how IAM is kind of implemented around them. So I keep harping on don't use the admin access policy if you're using Terraform today. Like if you're working in an environment using Terraform, go check and see what that policy is. Restrict it as much as possible. Use policies, roles, use all the controls that these cloud providers have to basically prevent the abuse of these pipelines. If you're not using, US West 1, just block the role from having access to US West 1. The conditionals that IAM has are really powerful, so you could prevent all of the examples of getting the STS credential and using it outside your environment by just putting conditional on where that role can be used. So there's really powerful controls built into IAM we should use as kind of the first step. And definitely monitor the roles as well. If things like policies and roles are changing very often, you need to know why they're changing and if it's an approved change. The other piece going into this, more on the architecture side, but understanding the patterns and building patterns for how these services are used is really important. So a lot of companies just kind of slap a pipeline together. They start writing Terraform. They build out, their EC2, their database, all their networking. They don't really ever document how this should be done. So that's kind of the first step you should take is documenting how you're going to use these services. So you go into it knowing what's going to be built, and you can build those guardrails against that pattern as well. And that leads to building these pipelines, having your Sentinel checks, whatever it might be, and then you have these really hardened services. So for example, for like RDS and EKS, two reasonably complex services, we have about 60 policies for each. So you deploy these services and have very hardened versions coming out the other side of it. So. And then obviously code review is an important piece as well. Using automated code review is really important. We can't scale to the point of reading every change in every Terraform plan that gets pushed out there. There's a couple other open source tools, TFSec, Terrascan, and Checkoff. Two of them are kind of backed by vendors, but they're still open source at this point. So definitely check out those, run those against your Terraform environments as well. Those don't look for malicious use cases, those look for misconfigurations, but still good tools to have. I kind of talked about this, but making sure you're monitoring your your IEM for your Terraform pipelines or any pipelines really to make sure it's still doing what you expect it to do. Knowing when any role changes, policy changes, whatever it might be, making sure that you're aware of those kind of issues. So yeah, hopefully you all learned a little bit from this, but I'm a big fan of Terraform. It's a great tool, both from a security and infrastructure perspective, but it is something you kind of have to know how it works and the edge cases and all the ways it can be abused. Yeah, thank you. Any questions? All right, cool. Well, the links to the module and the training is right there, so feel free to take a look at those and reach out to me if you have any questions. Thanks.